Hello everyone, welcome to this short tutorial. A dashboard system consists of a server side and a browser side. In this project, we use Python's Flask framework to build the server side. The server provides routing services to return required files to the browser, such as HTML files, JavaScript files, CSS files, JSON data files, etc. On the browser side, an HTML file defines the contents of the dashboard, a CSS file defines the layout and the visual effects, and the JavaScript files supports user interactions. In this project, we mainly use visualization widgets from the eCharts project for non-map visualizations and the Leaflet.js project for visualizing maps. In this example of the risk report, we can see how a text box can provide non-visual information to users directly, as seen with the crash probability. Text boxes can also be used for comparison purposes. Some visual efforts can be added to enhance information delivery. For instance, we can use red values for decreasing values compared to the previous month and green for increasing values compared to the previous month. Bar charts can help us to visualize a histogram, for example, the monthly number of trips or the weekly number of trips. A line chart is good for visualizing trend changes over time. They also have more interaction options compared to a simple bar chart. We are able, for instance, to zoom in to the data on the fly to check for more details on a smaller timescale. There are many approaches to visualizing big hotspot data. In this dashboard, we developed a quad-tree-based plugin for the web mapping library Leaflet.js that the Map Widget can use to visualize the hotspots at different spatial scales in a very smooth way once the dataset is loaded. Areas with more data points have smaller cells and a darker color. Users can also interact with the cells to access the values of the cell properties, such as shown here. In this process, no interaction between the browser and the server side is needed. The graph widget can be used to visualize network data. In this project, it is used for visualizing the individual mobility network generated from Work Package 4. In this example, node size, edge width, and edge color represent different attributes of the individual mobility network respectively. A heat map widget can help visualize data that is aggregated by two properties. In this case, it helps us to report the total events by month and by event type. We can use a dashboard to compare different maps according to different scenarios. For instance, we can compare different risk scenarios of sleep apnea and visualize the optimal locations and number of oximeter pickup facilities according to each scenario. Once the first view of the dashboard is loaded and demonstrated, its content can still be changed by sending queries to the server, which then receive the desired data. For a dashboard, the content of the queries is limited by using menus. We can use different types of controls, such as sliders and switches, to control the content of our dashboard. For instance, we can use the slider to select the desired number of additional facilities, and we can use the switches to change between different risk scenarios or to select a different background map. In this example, we use the tab controls to switch between different charts and demonstrate them to the user. We can use the dashboard to show and hide different map layers, such as density layers and point layers, to the user. Dashboard users may want to change the layout of the components so that they can prioritize specific information that they like. This is implemented in this dashboard as well. Users can use a drag-and-drop approach to reorganize the four sections according to their likings.